Welcome to our service training program on the theory of Clark-Hurth differentials. But first, a little about who we are. Since 1904, Clark has been an original equipment manufacturer of power shift transmissions and planetary axles for off-road heavy equipment. At our factories, we design and build components with one goal in mind: total customer satisfaction.
Looking at this, you can see where you may have any problems and if there are any needs to strengthen the areas that have high stresses.
Before Clark-Hurth builds prototypes, designs are tested by engineers who use cutting-edge technology to ensure product reliability. Developing and building newer and better drivetrain components has earned us the reputation as an industry leader. Now a short lesson in the theory of differentials. A differential is a device which transmits force and motion to the wheels, allowing the vehicle to make turns. What does the differential have to do with making turns? When a vehicle travels around a curve, the inside wheel slows down, while the outside wheel speeds up to travel the longer distance around the curve. Using a series of gears, the differential allows the wheels on the same axle to turn at different speeds. We will discuss four types of differentials: the standard differential, the limited slip differential, the posi-torque limited slip differential, and the no-spin differential. Here's how a standard differential works. The axle receives its power from the drive line through the pinion gear. The pinion drive gear turns the ring gear, which is bolted to the differential body. Inside the differential body is the spider gear assembly, a cross with pinion gears on each arm. The cross is clamped into the differential body. Fitted to these pinion cross gears are the side gears, one on each end of the differential body. These are splined on their inside diameters to accept the splined ends of the axle shafts. The entire mechanism is supported by the differential body, which is bolted to the axle housing. When the vehicle is traveling in a straight line and both drive wheels have equal traction, both wheels travel at the same speed. Remember, the pinion cross gears are forced to revolve with the cross, but they're free to rotate on their own axis when required. When the vehicle goes into a turn, the inside wheel does not turn as fast as it did in a straight line, but the outside wheel turns faster because it has a greater distance to travel. The side gears are attached to the axle shafts and must turn at the same speed as the wheel they're attached to. Since the side gears contact the pinion cross gears when they rotate at different speeds, it causes the pinion cross gears to rotate on their own axis. The gear assembly no longer turns as a complete unit as it did when both wheels were traveling at the same speed. The standard differential is good for many situations, but if a vehicle equipped with a standard differential loses traction on one wheel, the slipping wheel triggers differential action, sending available power to the slipping wheel where it is not needed. This takes power away from the non-slipping wheel. To avoid slipping wheels, some off-road vehicles require a differential that is a bit more complicated. The limited slip differential contains side gears that are splined on the inner diameter with teeth on the outer diameter. The differential case halves include internally cast lugs which hold the outer clutch plate stationary. The side gears are splined on the outer diameter carrying the inner clutch plates. With the case halves bolted together, the clutch plates are pressed against each other. When both wheels have equal traction and the vehicle travels in a straight line, the entire differential assembly turns as a unit. The clutch packs simply ride between the side gear and case half with no effect. But when the vehicle goes into a turn and both wheels have equal traction, the inside wheel slows down while the outside wheel speeds up. This causes the side gears to be forced from the pinion gears, pressuring the clutch plates to engage so that the wheels cannot slip. This lets each wheel turn at different speeds, with the clutch packs transferring some of the power back to both wheels. When a wheel slips, this mechanism prevents the slipping wheel from taking all the power. Clark-Hurth's posi-torque limited slip differential is designed to provide more torque than the conventional limited slip design. Like a limited slip, the posi-torque differential uses clutch plates to inhibit spinning and to send more torque to the wheel with the best traction. Posi-torque differentials come in two configurations. In the first, clutch plates alone are used to increase torque nearly 3 times to the wheel with good traction over that of the wheel with poor traction. This is referred to as torque bias. This configuration performs the same as a limited slip differential. In the second configuration, springs assist the action of the clutch plates, transferring as much as 5 times the torque to the wheel with the best traction over the wheel with the poor traction, creating a bias ratio up to 5-to-1. For some applications, it is important that both wheels have equal power all the time. This is a job for the no-spin differential. The basic design is the same. The ring gear is bolted to the differential housing and fits together with the pinion drive gear. The cross assembly is clamped into the housing. There is a key on the inside diameter of the cross assembly. It looks like a long tooth. A snap ring fits into a groove on the inside diameter of the cross and also fits into a groove on the outside diameter of the center cam when positioned inside the cross. The narrow slot of the center cam fits the key of the cross when assembled. The slot, which is wider than the key, allows the center cam to rotate, but just a short distance. The driven clutch member fits on either side of the cross and center cam assembly. With the driven clutch member removed, you can see that the rotatable holdout ring is held in position around the inner row of fixed clutch teeth. The gap in the holdout ring meshes with the bottom portion of the long tooth or key of the cross. The teeth on the holdout ring sit in the wide slots of the center cam. The inner row of clutch teeth on the driven clutch members fit between the teeth of the center cam, while the outer row of clutch teeth sits loose in the large gap between the teeth of the cross. If the two driven clutch members are held against the cross and center cam assembly, only the cross will move back and forth in the gap. The center cam, which is allowed to turn inside the cross, is held by the inner row of teeth of each driven clutch member. A return spring sits on the shoulder of each driven clutch member. A spring retainer sits up against the flange of each side gear. When the spring is compressed, the splined side gear fits into the spline-driven clutch member. Each side gear sits in either end of the differential housing and is splined on their inside diameter to accept the splined ends of the axle shafts. Supporting the pinion drive gear, ring gear, and the differential assembly is the carrier housing. It bolts to the axle housing to complete the assembly. When there is equal traction on both wheels, the whole housing and differential turns as an assembly. The two axle shafts are locked together through the side gears by the two driven clutches, which are positively locked to the cross and the ring gear. When the machine is traveling in a straight line and one wheel loses traction, the locked wheel action of the positive locking differential allows equal power to be delivered to both wheels. This is the main advantage of a no-spin differential. When the vehicle goes into a turn, the outside wheel, pushed by the swing action of the turn, is allowed to disengage and turn faster than the inside wheel to cover this longer distance in the turn. The inside wheel continues to drive the vehicle through the turn. Now here's how the no-spin differential works. If clutch member A is pushed faster than clutch member B, A's inner row of teeth will try and push the center cam along with it. B's inner row of teeth prevents the center cam from moving. Clutch member A finds it easier to push back the return spring and slide up the sloped teeth of the center cam than it is to push the center cam ahead. As clutch member A slides across the teeth of the center cam, the teeth of the holdout ring slide out of the shoulder of the center cam. The holdout ring then slides up against the key of the cross and stops moving as fast as clutch member A. Clutch member A is now being held out and away from the cross as it rides around the holdout ring, free to be pushed faster than the cross is driving clutch member B. As soon as clutch member B returns to the same speed as clutch member A, the holdout ring will slide back over the large slots in the center cam and the return spring will push clutch member A back into place. Both wheels will turn at the same speed. So there you have a basic explanation of the standard differential, the limited slip differential, the posi-torque limited slip differential, and the no-spin differential. Clark-Hurth parts availability is one of the best in the industry. More than $65 million in inventory is distributed through more than 200 original equipment distribution centers. Whenever possible, Clark-Hurth ships within 24 hours after receiving an order. Only Clark-Hurth is committed to that kind of genuine parts backup for emergency orders when a unit is down. In an emergency, our manufacturing and service parts support make your unit down our top priority. If you have a question, don't hesitate to call a Clark-Hurth parts sales representative.